Hey y'all, we are back, and right when you thought we were done with every type of asymptote ever, there is a new kind. Today we are talking about polynomial long division and slant asymptote. So if we look here, a slant asymptote looks like this blue line right here. This is because when we have an asymptote that's not horizontal or perfectly vertical, there can be a guiding boundary for a polynomial or rational function called a slant asymptote. How do you find one of these? You might be wondering. This is how you find one. So number one, in order for there to be a slant asymptote, the degree of the numerator is exactly one higher than the denominator. So let's look at this one. If I compare the degrees here, the numerator degree is 3, the denominator degree is 2. This one is exactly one higher than the bottom, so this does have a slant asymptote. So how do we find it? Okay, so in order to find it, number one, the leading coefficients of each other is 1 over 1. So the slope of the leading coefficients is 1 over 1. If I look here, I can see that up 1 over 1 is the slope. Up 1 over 1 is the slope. We can see that as it goes. But how do I know the exact function or the exact equation of that slant asymptote? So this is where we look at it. We would have to divide. So to find the equation of the slant asymptote, we're going to divide. Okay, there's two ways to divide this. You can use long division, which remember we take the divisor, put it on the outside. The numerator goes on the inside. Oops, minus x plus 2. And you're going to take your first term into the first term, and we're going to divide first. This is our first step. So what is x squared divided by x? It's just x. And then we're going to multiply back. So we're going to multiply it back to here, and here we get x squared times negative 3x. So we've got this. And then we're going to subtract. So when I draw the line and I'm going to subtract, these are going to change their signs because we're subtracting. X squared minus x squared cancel. That's what they're supposed to do if you do it correctly. Negative x plus 3x gives me 2x. And now we're going to bring down that positive 2x as our last step. And now we start again, okay? So again, we're going to take our first term, divide it into our first term. So what's 2x divided by x? It's just 2. This is a positive 2, and now we multiply back. 2 times x is 2x. 2 times negative 3 is negative 6. We're going to subtract. These cancel if I do it well, and I get 8. This last 8 is the remainder, okay, which means this is a plus 8 over x minus 3. When it comes to the slant asymptote, we only take the part without the remainder. So for the slant asymptote, it'll be y equals x plus 2. Disregard the remainder. Okay, so let's say, what if I wanted to do this in synthetic division? Well, remember, synthetic division means I'm going to take the divisor, set it equal to 0, and I get x equals 3. This x equals 3 is what I'm going to use in my synthetic division, and then I only use the leading coefficient. So if it's x squared minus x plus 2, I know my leading coefficients are 1, negative 1, and 2. So I'm going to put that 1, negative 1, and 2 here. Leave a space, draw your line, bring down your first term, and we multiply the bottom number times the box, and it goes here at 3, and then you're going to add down. So negative 1 plus 3 is 2. Again, the bottom number times the box is 6, and add down. This is our remainder, and remember this stands for our constant term, and this is our x to the 1. So this is our x to the 0, here's our x to the 1, and so on to the left. So our y equals 1x plus 2, and again we disregard our remainder of 8, and so our slant asymptote is just y equals x plus 2. So what if we were looking for slant asymptotes here? So here I want to double check, does this have a slant asymptote? This is 2, this is a degree of 1. Yes, there's a slant asymptote. Here you could do one of two things. You could either use long division, or you could use synthetic division. And remember, synthetic division, usually we're used to seeing things like this, where it's just a constant linear term, x minus 3. Okay, but this is technically a linear equation, but that x is not alone. It's 2x plus 3. So what you're going to do is go ahead and set this equal to 0 and solve it. So subtract by 3. And we get 2x equals negative 3. Now, we have to divide by 2 here to get it. So we get x equals negative 3 over 2, or negative 1.5. So I can use synthetic division with negative 1.5 in the box. The only thing is, because I had to divide this by 2, I also have to divide the numerator by 2 in order for this to work. So if I divide 4x squared by 2, I get 2x squared. 2x divided by 2 is plus x, and 7 divided by 2 is negative 7 over 2, or 3.5. We're going to use this as our coefficients instead. So 2, 1, and negative 3.5. Again, if you don't like having to do all this for synthetic, you could use long division again. Bring down the 2, multiply bottom times the box. We get negative 3, add down, multiply, add down. Again, we disregard the remainder, and this is our x to the 0. Here's our x to the 1, so we get our slant asymptote is 2x minus 2. For this one, if I'm dividing this, our denominator is exactly 1 less than the numerator, so there is a slant asymptote. And because this is not a linear equation on the bottom, we must do long division. So here we go, 2x squared plus 3x on the outside, and then we take 6x cubed plus 13x squared, and then this minus 5 goes out here because we have a missing term of 0x. So we're going to put that here because we don't want to have any missing terms. So now we're going to take, again, we're going to divide the first term by the first term. So 6x cubed divided by 2x squared leaves me with 3x. This goes here. We're going to multiply it. So we get 6x cubed plus 9x squared, and we're going to subtract. This will cancel. We get 4x squared and bring down the rest. And then we start again. Divide the first term by the first term. 4x squared divided by 2x squared leaves me just 2. So this is going to be a positive 2 here. And now we're going to multiply it back. This becomes 4x squared plus 6x. And now we're going to subtract. Oops, hold on. This cancels as it should. It's negative 6x, and bring down your negative 5. There's nothing else to divide by here because this is a smaller value than this. So this is technically your remainder, but again, we disregard a remainder in synthetic division. So our answer here, synthetic division, or our slant asymptote, is y equals 3x plus 2. Okay. And let's talk about what this would look like, how this changes our end behavior. So again, this problem here is the same one here, right? It's the same problem, 6x cubed plus 13x squared minus 5 all over 2x squared plus 3. So I know that the slant asymptote is y equals 3x plus 2. So I don't know exactly what that graph looks like, but I know 3x plus 2, if I sketch that, that's up 2, up 1, 2, 3 over 1 like this. It looks something like this. And I know the graph has to follow this boundary, okay? So here's what I know. The end behavior on the left, so the limit as x approaches negative infinity, what is g of x doing? Well, I know it has to be following what's happening on the left here. Well, where is it going? It's going down to negative infinity. And that the limit to the right as x approaches infinity, g of x is going where? It's got to be going up to positive infinity. All right, that's all we have for today. We'll see you next class.